Hello everyone, welcome back to Coding Trades. So in this session we are going to see about Numpy. So you will see what is Numpy and how to use this Numpy and how to install this Numpy module. All these things you will see now. So before that we will see that what is Numpy is. Numpy, we can say that it is a numerical Python which is of library. It is in Python library which will work with arrays. So we don't have any special things for the array, so we are using Numpy. We can also use lists, but it is far better than list. Numpy is far better than list because it is very faster, we can say. And in this Numpy, we can use like Fourier transform. We can use numerical things like Fourier transform, and also matrices, and also linear algebra. All these things, all these domains we can use. And actually this Numpy is created in 2005 by Travis Oliphant. He is the one who created this Numpy. And we can say that it is an open source project which can be available freely in the market. In the internet. And it is Numpy is a general purpose array processing package. General purpose array processing package, and it is having high performance for scientific computing. And why we use Numpy? We are already having this list which will support few of the arrays, right? So, but why we are having? Why we are going for Numpys? Because lists are slow process when compared to the Numpy. So it is 50 times faster than this thing. List is 50% less than Numpy. So we can say that Numpy is very fast. And we can say that the array object in Numpy is called as ndarray, as it is supporting multi-dimensional arrays. So we can call it as ndarrays. And in arrays, the Numpy are stored in table of elements like rows and columns is stored. And the dimensions of the array is called as rank of the array. So what you call this dimensions is, if it is zero-dimensional array, the rank of the array is 0. If it is one-dimensional array, the rank of the array is 1. If it is two-dimensional array, the rank of the array is 2 in that way. So we can also call it as ndarray if it is having n-dimensional array. And these are the things you should remember, very important things. This is the rank of the array and the shape of the array. The rank of the array is dimensions of the array. The shape of the array is couple of integers giving the size of the array. So it will give it is having very efficient manner. If we are having in a table, then it is very efficient. Or rather than storing in different locations, if it is storing in continuous places, then it is having efficiency more. So that this behavior is called as locality of reference. So this is the main reason why we are going for the Numpy, because it is faster than list. So which language is this Numpy written in? Numpy is written partially in Python, and for faster communications written in like C or C++. So next is how to install the Numpy. So it is very simple. You can go with this command, because with the PIP we can install all the libraries. Whatever the libraries you want, you will go with PIP space install space. Whatever the library you want, you will go with this. So let me install this PIP or in Numpy. Actually, I'm already installed with this. So let me show you. PIP space install Numpy. So if it is not having in your system, then it will give you Numpy, whether Numpy is installed or not. So let me check. So I will give the simple example like how to import or how to work with the Numpy. So here I am giving like import Numpy. So if it is not installed, then you will get a skewed and red underline here. So you will get like this. So you can see, like, if I am going to install, like if I am importing Kiwi module or if I am importing anything, so you will get this red underline. So this Kiwi is not installed in my system, so I am getting red line. So as I have installed NumPy, I will not get this red line, which will go. So this is what the confirmation you can see. And also you can check the version. I will show you how to check the version as well. So here I am importing the NumPy and I am using the variable ARR to store this array. ARR equal to NumPy.array. In your mother will call you different name and your friends will call you different name, right? So we can also call this modules or this libraries as other name. So how can you call this as with the other name is import NumPy as NP. Whatever the new name you want, you will give with the help of as followed by the name you want. And see here, you are getting the red underline, skewed underline. So you can call this as, so we are calling with the other name, right? So you should call with the other name here as well, np.array. So now you can see, so I will, for difference, I will give like 6, 7. So here already it is 1, 2, 3, 4, 5. So now you can see the difference. So you will get 1, 2, 3, 4, 5, 6, 7. So when you are giving the alias name of this NumPy, so you should access with that alias name itself in np.array. So this is how you will use it. And next, as I have told you, version, how to check the version. So np.__ version, you can get the version. What version I am using? This NumPy. When I am recording this, so we have already studied this type method, right? So if you are giving this type, what you will get is what type it is. The array is of what type, which data type or which type it is. So it is of type NumPy.ndarray. So this ARR is of type ndarray, NumPy.ndarray. This is what it is given. So next thing is, so we know that what is the type will do, and we can see. So next thing is so it will not only support the list, but it also support the tuples. So here we have given the list. Now I am going to give the tuple. So this is what tuple. So let me import the array NumPy. As I have removed, import NumPy as NP. So here I have given the tuple. So whether you will get the tuple or not, let us see. So you can get the tuple also in the format of array. This is how you will get it. So next thing is dimensions. So what do we call this dimension? Just now we have studied, right? So just pause the video and recall it and post it in the comment box. So this dimensions of arrays we can call it as rank of the arrays, right? So this is a 0-dimensional array. So I have given only one single element. So it is called a 0-dimensional array. I am giving here one dimension as we have seen in the earlier examples. So this is what? One dimension. Next. So let us see this example. All the ranks you will display. How to display the ranks you can see here. So here I am going to display you the ranking of the array. Sorry, import NumPy as NP. So array equal to np.array, array with rank 1. So you can see that this is the rank 1 and this is the rank 2. And here I pass the rank with the tuple, array created using pass tuple. So you can see what you will get. So array with rank 1. And this is with array with rank 2 as we have given here rank 2 and the next one is passing the tuple. So this is how you can do with this. So the next thing is accessing the array index. So we know that how to access the array index, like we have seen in the list as well. So you will start with a of 0 or a of 1 like that, right? So let us see here how to access the array. So this is what the simple example how to access the array. So let me copy this. Then I'm copying, pasting here. So you can see the output here. So how you will get this array? So array equal to, I have initialized this array here. And then I'm printing what is the initial array here. You can see here the initial array, whatever the array here we have given, it is stored in ARR. So you will get the initial array, and then here I am going to slice the array. So we have seen how to slice, right? In the list also we have seen. So colon 2, that means what we are accessing here, only the first 2 rows. We are accessing only the first 2 rows. And here I am giving stepwise 2. That means leave 2 and access the remaining. Leave 2 and access the remaining ones. Like that. So you can see here minus 1 and then 0. So minus 1 then 0. Leaving 1 then accessing. So you will get 4 and then 6. Then, so since we have accessed only 2 rows, it is given only 2. So leave 1 and get 1. Leave 1 and get 1. This is the position, it is 0 and 0, right? So what we have accessed 1, 3, right? So this is the position of 1, 1, 0, 1, 1, 1, 2 and 1, 3. This is the position of 1, 3. So first one, 1, 3, you got it as 0. Next one, I am accessing 1, 2, which is this one, 6. Next I am accessing 0, 1, this one. And next I am accessing 3, 0, and this is the one. It is starting with 0, 1, 2, 3, so we will get 3, 0 like this. So this is how you can access the array elements. Next thing is how to check the number of dimensions. So we are giving different number of dimensions. We don't know how many dimensions we have given. So in that situation, how can we check the number of dimensions? So we will give the array, and I am printing here initial array, and I am slicing the same example. Sorry, I have copied the same example because I want to give the same thing. Okay, let me paste this. So with the help of ndim is n dimension. With the help of ndim, you can check which dimension of array you are using. You are giving as 0 dimensional or 1 dimensional or 2 dimensional or 3 dimensional or n dimensional. You can check with ndim. You should remember this ndim. So I am importing numpy and I am saving this. I am using the variable and I am giving the array. And I am calling a.ndim because a is the variable which I have stored the array. So a.ndim means ndim will give the which dimension of array it is. So it will give you 0, and as I have given here 1 dimensional array, b.ndim will give you 1, and I have given here 2 dimensional array, it will give you 2 and then 3 like this. This is how you can access the with how many types of like how to check the dimensions of the array. Then if you are giving the if you want to give the high dimensional arrays, you have to create an array with 5 dimensions and verify that if it is 5 dimensions or not. So let us see this simple example. So creating like n dimensions. So here I am creating 1, 2, 3, 4 as a single dimensional array, and I am creating n dimension is equal to 5, and I am printing the array. You can see what is the array here, and I am accessing here arr.ndim. That means I am requesting that which dimension it is. Either it is 5-dimensional or 6-dimensional or 10-dimensional, like that. So here we can see the number of dimensions is 5-dimensional array. So for this I am giving here 5 dimension. So here I am mentioning that it is 5 dimensions. So if you mention here it is 10 dimensions, if you give here 10 dimension and then if you run this, then you will get 10 dimensional arrays like this. So with the help of NDIMN, you can specify how many dimensions you want. And with the help of ARR.end, you can get the number of dimensions you are giving. And then, so to create sequence of numbers, we can provide NumPy. And also apart from this, we are having different things like arrange, linspace, and reshaping the array. Arrange, linspace, and reshaping the array. So what is arrange will do? So this arrange will returns the evenly specified values at given interval. So just now we have seen the 2 when we are doing the slicing. So with a given interval, it will return. And linspace returns evenly specified values within a given interval. So even specified values it will return. And reshaping the array. So reshaping the array, with the help of this you can reshape the array. For example, you are having A1 to AN, and if you want to reshape, to convert it into another shape like B1 to BM, then this is the required, like what A1 into all these things, A1 into A2 into AN equal to B1 into B2 into BN, all these things. That means the original size of the array should be same. It should remain the same. Then only we can reshape the array. So this is how you can reshape. So we are also having the flatten array. So what is this flatten array will do is, it will we can use this flatten method to get a copy of array collapsed into one dimension. So if it is collapsing into one dimension, you can use this. So by default you are having row major order, that is C. If you are doing with the row major example. So here I am creating the array and with the data type float, D type as float, and I am printing the array. So you can see whether we will get it in float or not. So you can get it in pass, the array created using pass list. So 1, 2, 4, 5, 8, 7. So just you are getting this array, and so this array is of type, and then this is of creating tuple, creating array from the tuple. np.array 132, and array created using passed tuple. So you will get as passed tuple as 132. Whatever we are passing, you will get. See here, I am giving here just 3 by 4, 3 comma 4, np.0 3 comma 4 I am giving. That means you will create a matrix with 3 by 4 matrix, and then you will pass all the, you are giving all the values as 0. So you can see here, it is a 3 by 4 matrix and you are giving all the values as 0. And create a constant value. If you want to create a constant value array of the matrix, that means if you are using the complex functions, so you will add up these things like you will get the 6 plus addition, subtraction, multiplication, whatever you want you can do with the array. So here I have given the array 1, 2, 3, 4, and I am giving the second array, B array as 4, 3, 2, 1. I am giving the 2 arrays here, and I am adding 1 to each element. 1 to each element. You can see the output as well. So here this is adding 1 to each element. So 1 plus 1 is 2, and 1 plus 2 is 3. 3 plus 1 is 4, and 4 plus 1 is 5. So you will get the resultant matrix as 2, 3, 4, 5. So you can check here 2, 3, 4, 5. This is what adding 1. And I am subtracting 2 from the B array. So from here I am subtracting 2. So you can get 4 minus 2 is 2, 3 minus 2 is 1, and 0 and minus 1. So you can check here. This is what subtracting the elements. So after adding, you will get one array. After subtracting, you will get the other array. Then sum of all the array elements, A dot sum. So here I am summing up 1 plus 2, 3 plus 3 is 6 plus 4 is 10. So if you want to sum up all the array, you will use a function called as A dot sum. So it will sum up all the elements of the array. And then I am here doing 5. 3 plus 2 is 5 and 4 plus 1 is 5. Each and every element will be added to the other array element. Then you will get the resultant array. So this is how you will do. Then next, unary operator. So just now we have seen a simple example with sum, right? So you will get also min, max, etc. all these. So you will call just array dot max. Then you will get the maximum element of this array. So you will see now. So you will get maximum element, minimum element, all these things you will get. So I am calling the maximum function here array dot max. So among these the maximum is 9, right? So the largest element is 9. So here I am calling array dot max. So when I have called here axis equal to 1, it is row wise. When I have called here axis equal to 0, it is column wise. We should remember that. If it is 1, it is row wise. If it is 0, it is column wise. Largest element among rows is, they are asking. So row wise maximum element is 6, 7, 9. Cumulative addition. Cumulative of all this. So for that, what you are using? CUM. So this is about the cumulative sum. If you are using these methods like sum, max, min, cumulative sum, all these things you will get. So if you want to do the binary operations, you will give here as A plus B for the addition of the two arrays. You will give A cross B and A dot B. Sorry, A multiplication B, A dot B. This is the dot product and this is the multiplication. And coming to the universal functions. So universal functions like exponential, square root and sine, cos, all these comes under universal functions. So how can we do with the help of universal functions? So here I am giving here as pi. So we know that pi value 3.14, it is a universal value, right? So I am giving here pi by 2. np dot pi by 2 is here I am assigning 0, np dot pi by 2, np dot pi. And I am using that sign values of array elements, np dot sign of A. So you will get the sign value. You will get some like decimal value here, 3.14 by 2, like that. So you will get the sign value and you will get the exponent of this and you will get the square root of this. So you have a look at the output so you can understand. So it is 0.0.0.0 plus 1 raised to the power of 10 and then 1.000 like that, 1.224. So this is how you will get. The exponent values are like 1, 2.7 something and then 7 point something and 20 point something. Square root values are like 0, 1, 1.4, 1.7. So this is how you will get all these things. So you can use square root, exponential, sine, cosine, all these things you can use with the universal functions. Whatever the universal functions we have, we can use this. So this is about the introduction of the NumPy. So in this video, we are going to see about NumPy array accessing, like how to access the array and how to do simple operations like addition or subtraction, like that. All things we will do. like mainly we are focusing on how to access a different dimensional, like if it is 2-dimensional or 3-dimensional or n-dimensional, how to access the elements from that array we are going to see now. So in our previous video we have seen the introduction. I would highly recommend that if you haven't seen that video, please watch that video and see this, so that because I am using the extension of that, so it will be helpful. So let us look into that. So this in the NumPy array indexing, like we will also go through that slicing. What is slicing, integer array indexing, Boolean array indexing, all these things we will see. So what is slicing is, we have seen in the list like how to access the elements. Like for example, if I am using like for example the list is like 1, 2, 3 like this. The list is consisting of 4, 5 elements, 5 elements. So if you want to access the middle elements, or if you want to access only 2 elements, how you will access? Just you will pass like with the square bracket :2. Then you will get the first two elements, right? So this is how in the same arrays we can also pass like a single row as a list we can pass. That is what integer array indexing. And the next is Boolean array indexing. So what is this Boolean and array indexing is, if the condition is true, then you will pass the list or the array. Like for example, if condition is greater than 0, then what are the array indexing values? You will get all those values from that array. So we will see all these examples in a while. So this is what about these three, and let us see how to access the array elements. So like in the list, the arrays can also be accessed with the help of index number. So the starting element of the index number is 0, the next element is 1, next element is 2, and so on like that. Like same in the list, we have seen like first element is you will call with k of 0, or like the 0 element, first element like that, right? So in the same way we will call the array elements like list. So the next one is, so if it is the first row, then you will go with this. So we will see all these things in detail with the help of programs. So this is what the first element. So I will copy this and I will explain you. So this is what I am importing. All these things we have seen in our previous video, right? So you will get it as 1. If you are passing like error of 1, then you can expect 2. So now you are getting 1. Since it is 0. So array will start with 0. So next is, if I am passing 3, then what you will get, you can see here. So it is 4. 0, 1, 2 and 3. So if I am passing 4, what you will get? So we have seen in exceptions, errors and exceptions, right? So what you will get here, you can observe here. So fourth element is not there. So you will get array index error here. So it is index 4 is out of bound. So this is what one of the error or the exception you can see. So this is the error, index error. We have seen in the errors, right? So this is how you will get the errors. So next one is, so if you want to access all this like 0, 1, 2, 3. So this is how you will access. If it is 0, then you will get 1. If it is 1, you will get 2. If it is 3, like this, 0, 1, 2 and 3, you can access the values. So here I am given error of 1, so I can expect 2 as the output. So if you want to add the elements, so what you will do? So this is a simple example, like to add the operations. So I'm adding 2 and 3, that is 0, 1, 2 and 3. So 3 plus 4 I'm adding. Array of 2 and array of 3 I'm adding. So you can expect the output as 7, right? Because 3 plus 4 is 7. So you are getting 7. So this is how you can do the operations. If it is minus, you can also perform minus. If it is division or subtraction or multiplication, whatever it is, you can perform all the operations here. So I have shown you subtraction, and I'm going to show you multiplication. So all the operations you can perform like this. So if it is two-dimensional array, so now we have seen the single-dimensional, one-dimensional array, right? So if it is two-dimensional array, so how can you access the values? So as we have seen, I have told you that it will be passed with the help of lists. So you can see that I have passed with the help of list with the two-dimensional array or the one-dimensional array. I have passed with the help of list. So this is about indexing a thing. So next I'm accessing here second element of the first dimensional array. So I'm accessing the first element. First element is 2. So 0, 1 means you will get 2. Second element of first dimension is 2. So if you want to access the next element 3, then you will call it as 2 here. So you can expect it is 3. So okay, fine. Till now I have accessed this this list. So if you want to access the next one, what about this? How can you access this? It's a question mark, right? So for that, what you will do here is, so array will be starting with 0, and then what is the next one? It is the 1. The next one is 1. So I will go with 1 here, and if I want to access the first element, then I will go with 0. If I want to access the second element, 1, and then third element is 2, like that, 0, 1, 2, 3, 4. So here I am accessing third element for the first dimension. So I am getting 8. So this is how you can access the two-dimensional arrays. So now we will see some more, like accessing the fifth element we have seen, right? Fifth element of second dimension. We have seen how to access the second dimension. So how to access the 3D arrays? So this is what the important thing. How to access this three-dimensional array. So for the three-dimensional array, we will consider this as a single list and this as the second list. The whole one we can while we are accessing, we will consider this as a 0 and we will consider this as 1. So I am accessing this as 0 and I will consider this as a 1. So I am accessing what in the 0th dimension? First one. That means this is a 0 and this is a 1. In the first one, I am accessing the second element. So 0, 1 and 2. So I can expect the output as 6. So this is what about 6. So if I want to access the next dimension, how can I access? As we have seen, so 1, I will replace here 1. And then if I want to access this list, so I will go with 0. So this is the 0th list. So 1, so this is considered as 1 and this will be 0 and I am accessing 0, 1 and 2. So if I want to access the element called 9, then I will go with 1, 0, 2. So let's see. Yes, it is 9. So if I want to access the second one, this one, second list. So what I will do, I'll just simply make it as 1 because this is the first one. So this is the 0th one, this is the first one. So 1, 1, 2. So what is the second element? 12 is the second one. So I will get it as 12. So this is how you will access. So if you want to access this list 4, 5, 6, then what you will do? You will go with 0 and then this is the first one. So in the 0th list, this is the first one, right? Then 0, 1 and 2, 6. You will get it as 6. So this is what about three-dimensional array, accessing the three-dimensional array. It will start. So I am accessing here the first list. So this is the 0th list and this is the first list. So first list, -1. So -1 means 10. So negative values will start with 1, 2, 3, 4, 5 like this. So let me run this. So you will get it as 10. So if you want the third element, so what you will do? You will use -3. You will get it as 8. So this is how you can work with the negative indexing. So slicing. So what is this slicing is? If you want to access the between values like 2, 3, 4. So how to access these values in between values? So you will go with slicing. So for the slicing, what are the things you should specify is you must and should specify you should specify starting and ending of the list of the array, and you should also specify step. If you want any step, you should specify the step also. By default, if you are not specifying starting, then it will consider as 0, and if you are not specifying the end, it will consider the final number. So if the array is starting from 0 to 9, so it will consider from 0 to 9. Starting is 0 and the ending is 9. So if you want the step, that means if you want any difference, like if you want to skip any elements of the array, you will go with step. You will n-1, that means 4. From the first element to fourth element we can get. So 0, 1, 2, 3 and 4. So till 5 you will get from 2 to 4. 0, 1, 2, 3 and 4. So you will get like this. I'm accessing 2, 3, 4, 5. So if you won't give the starting element, element, then you will get 1, 2, 3, 4, 5. That means it will consider as the 0. So if I give the starting element 0 and if I won't give the ending, so it will give the full array. We will consider the whole array like this. So next let us see the step count. So how can I give the step count? So the step count can be given as, so if I want to get the elements from 0 to 8, so 0 to 7, let us say 0 to 7, and if I want the elements like skipping 1 and entering 1, skipping 1 and getting 1, skipping 1 and getting 1. Like that, if I want, then I will give the step count as 2. So if I want to skip 1, I will give it as 2. So see here the output. So I got it as 1 because I am starting with 0. So I will get it as 1 and I will skip 2 values. So this will be n-1, right? So I will skip 2 values. Then I will get 1 value. So you can see the output. So I will skip, I am getting 1 and I am skipping 2 and 3. Then I am getting 4. Then again I am skipping 2. I am getting 7. This is what about slicing. So even I can get without this also. So I can also give 2 colons. So from the starting to ending it will take. From starting to ending it will skip 3 and it will give you the output like this. So from starting to ending, skipping 3 values. So 1 is there and then I skip 2 values. Then 4 I got, I skip 2 values, 4 I got. Because here n-1 we will take 3 minus 1, skipping 2 values. So this is how the step will work. So the next thing is, so we have seen the slicing. So you can also use colon 4 means first 4 values you will get. So you can also give negative slicing as well. So negative 3 to negative 1 like this. So you will get negative 3. So 1, 2, 3. Negative 3 is this one, minus 5. And negative 1. So you will get with 1. 6 you will get as the output. So we have seen the step values. Like slicing two-dimensional arrays. How you can slice with 2D arrays. So let us see this. So slicing two-dimensional array is also same as the one-dimensional array. So here you can see. So I am accessing 1. That means this is 0 at 1 and this is first one. And from the first one, what I am accessing slicing is from first to 3 numbers I am accessing. So 0, 1. And then 1 and giving 1. So let us see this also. So from 0 to 2, see here, I'm skipping 1 and I'm getting 1. So 3, I got it as 3 first and then I got it as 8. So this is how I can get. So from the 2 list, I got it like that. So 0, 1, 2, 0, 1, 2. So I got 3 and 8 elements. So this is how you will access the elements. So if you want slicing from 0 to 2 and 1, 4, so you will get these elements. And let us see a simple example with slicing Boolean values, as I have told you, Boolean indexing. So let us see this one also. So I am giving here array, for example, and I'm giving slicing over here. So what I'm doing here, as we have told, colon 2 is I'm accessing the first 2 rows, and I have given here step value is 2. That means skipping 1 and you will get 1. So can you expect the output from here? So you will skip the values 1 and then you will get the value. So you can see the output here. Yes. So minus 1 and I skipped one value and I got 0. Skipped one value, then 4, skipped one value, and then 6 I got, skipped. So this is how I will get. So for the next one, 2, this is 6. So in similar way, all these things, 2, 1 and 3, 0. Like so next thing is, here I am passing the Boolean values, Boolean indexing. As we have mentioned that 3 indexings, right? So this is the Boolean indexing. So what is this Boolean indexing will do is, here I am giving us if the array is greater than 0. So here I am asking the condition, if the array value is greater than 0, then what I am trying to do, I am temp equal to array of condition. I am checking here. Then I am printing the values here, elements greater than 0. What are the elements greater than 0? Is minus 1 is greater than 0? No. Is 2 is greater than 0? Yes. Is 0 is greater than 0? No. Is 4 is greater than 0? Yes. So you will print all the values which are greater than 0 here. So if you want less than 0, what you will do? You will print here less than 0, then you will run. So you will get minus 1, minus 0.5 and minus 7. So if you want equal to 0, that means if you want both the values like arrays. So in this session we are going to see about NumPy data types. Which data types will the NumPy support and what are the things it will support, we will see now. So let us get into that. So NumPy will support strings, integer, float, Boolean and complex. These are the different data types NumPy will support. You know that strings, like if you are enclosed with double quotes, it is called as a string, right? So this next one is integer. Integer means like it may be positive numbers, it may be negative numbers, like that, like minus 1, minus 2, minus 3, 1, 2, 3, like that. So next one is float, which is having the decimal numbers like 0.2, 1.2, 42.42, 2.0, 3.0, 4.5. All this comes under float, which is of decimal numbers. Next one is Boolean. We know that Boolean is always 0 or 1 or true or false, like that, right? Next is complex numbers. So what is this complex numbers is? It is the numbers which are represented in the form of a plus ij form. So it will be a plus ij form, where we will write the values of a and I. Like here I have given a simple example. Integer is like -1, is having the sign, right? -1 is having the sign, so it won't come under unsigned integer. It is having sign, so it comes under signed integer. So whereas unsigned integers is 1, 2, like this. So this is what about unsigned integers. Then float, complex float, time delta, datetime, we have already seen about these things, right? So next is object, next is string. So we can also represent with one letter. So U is UniX string, V is fixed chunk of memory for other type like void, other type of data types. So we are also having like if we want to check the data type, so which data type it is. If we are giving some numbers and if we want to check which data type it is, so we are having a property called D type. We are having a property called D type. So with the help of this D type, we can check or integer or what it is. So it will give us int 32. Int 32. It is of integer. It is of having 32. Int 32. So you are having 32 and 64 like this. So you are getting int 32. So we will see one more example which is of string. So you will get this, what you will get for the string you will see. So here what I have told you that if we are having, if we are enclosed with either double quotes or with a single quotes, it is, we can conclude it as a string, right? So this is one string. So here I am checking what type of data it is. So let me check what type of data. So U6. U6 is select string. Next thing is how to create array with a defined data type. So here I am giving example, well, like which type it is. So just now we have seen with a single digit, right? So sorry, single number, a single letter, like D type equal to capital S. So what is this capital S will give? It will give us string, right? So this here I have given as a list array. So but it will show you as a string because here I have given the string. So let us check the output what it will give. So here I am printing the array. So it is B1, 2, 3, 4 like this. B1, B2, B3 and B4. So like this it will print because 1, 2, 3, 4 comes under string. You can see with the single quote we have mentioned, and I am getting integer type. It is of 32. So here I have mentioned integer of, and the size is I4 I have mentioned like that. Next we will see some math operations performed with the array. So with the array we can transpose the array. We can do whatever the operator, square root I have performed, maximum, sum, all these things we will see. So here I have given array equal to np dot array. I have initialized the array. And I have given d type equal to np dot float. So I am initializing this as a float type. So what is a float type? It will give 4.0, 7.0 like that. And then for the second array, I am giving here as 3, 6, 2, 8. I have initialized two arrays. First array and the second array. Then I am performing here sum. Sum equal to np dot add array of 1 and array of 2. I am performing addition of these two arrays. So 4 plus 3 is 7 and 7 plus 6 is 13. 2 plus 2 is 4 and 6 plus 8 is 14. So you will see here 7, 13, 4 and 14. This is about sum. Here I have performed the sum addition of the two arrays. Then I am performing np dot sum of arr of 1. So I am performing only this addition. The sum of all the numbers like 4 plus 7, 11 plus 2, 13 plus 6, 19. So I am getting as 19. Since I have given here float, so I am getting 19.0. So this is about summing of square root, np dot sum, all this it is already predefined methods. So here I am doing the transpose of the array. So how can I do the transpose of the array? It's a big question mark, right? So don't fill that. So here we are already having the built-in function called t. So I am using arr1.t. So this built-in function, it will transpose the array. Transpose is nothing but what? It will convert the rows into columns and columns into rows. It will interchange rows and columns. That's all. So here, see here, I am having the array as 4, 7, 2, 6, right? 4, 7, and in the down you will get 2 and 6. So while you are transposing, you will get the array as 4, 2 and 7, 6. This is how you will transpose the array. So this is about doing the square root and doing the transpose of the array, all these things. So now let us get into the next concept. So what if the value cannot be converted? So if the value cannot be converted, like if you are giving string and if you are performing addition, like that, like if the value cannot be converted, so what you will get is you will get the error called as value error. So this is how you will get. So see a simple example for value error. So here I am passing the integer. So here I am passing the string. Let me give you. Here I am passing the string a, 2 and 3. So here I am using the integer. So what it will give? So you can see the output. It will give you the value error because a is of integer type, invalid literal for int with base 10. So that is how you will get the error. So next, converting data type on existing arrays. So if you are having already one array on the existing array, how you will convert? So you will have a special function called as type. You will have a special method called as type. So it will convert it into the type which you want. So here I am passing I. So I is nothing but integer, right? So it is having float. So this float will be converted to integer. How it will convert? You can see. So see here, 1.1 is converted to 1 and 2.1 is converted to 2, 3.1 is converted to 3. And here I am asking which data type it is. So it is of type int32. This is all. And also you can pass like int. You can also pass int. We have seen this integer, right? So it will also give the same type. 1, 2, 3 and int32. So you can use a single word, single letter, and also you can use the full data type. So this is how you can do. So next, true. And which data type it is? It is of Boolean data type. So this is how you can perform. Next thing is NumPy array and copy. Array copy versus view. What is the difference between copy and view? What does the copy will do and what does a view will do? So what is this copy and view is just for copying. So copy, what will the copy will do is it will copy the new array. It copies a new array and the view will be just as the original array. View can be viewed as an original array. Like whatever the array you are giving, it will give you the original array, whereas copy is a new array. So for the copy, what you will do is, if you do any changes to that original array, if you are adding the elements or if you are deleting the elements, it will not affect the original array. As it is, whatever the array is there before, it will remain the same. Whereas view, if you are adding any element or if you are deleting any element of that view from the view array, then what it will give is it will change the original array. So for example, if you are adding an element to the array, so you are adding 42 to the array or you are adding 30 to the array for the existing array. So what the view will do is it will change the original array and it will first value you will get 42. And I am printing ARR and I am printing X. So you can find that original array will not be changed. See, it is adding 42 and finally it is printing the whatever the original array it is. So it will not affect for the original array. Whereas view, if you are going with the view, you can see here. If you are going with the view, it will affect to the original array. So here I am giving here. Let me import numpy. It is giving error. Import numpy as np. So here you can see that I am passing the view. So I am giving here view. ARR.view, and I am adding the first value as 42. The ARR of 0 is 42, and I am printing array and I am printing x. So it will affect the original array as we have studied. View will be affected with the original array. So you can see here. This is what the difference between copy and view. So copy will affect the original array, whereas view will not affect the original array. So this is about copy and view. Then how to check your own data if the array is having its own data or not. So you can check by base object. You can check like this. So here I have given one example. If the attribute is having the base, then it will return the none. Otherwise it will show you the data. So if the attribute is affected, numpy array shape. So we have seen the reshaping of array, right, in our previous session. So how to reshape if you are having both the arrays, A and B arrays, if you are having both the same sizes, then you can reshape the array. But what is about the shaping of an array? Here you will see. So for the shape of an array, you will get the dimensions as well as you will get the number of elements. So here what is the dimension of the array? So it is 2-dimensional. The rank of this is 2 because it is 2-dimensional array. And how many elements are there? 1, 2, 3, 4 elements. So you are getting 2-dimensional array and 4 elements. This is how you will get the output of the ARR.shape. That means it will give the first element as the dimension and the second element as number of elements in an array. This is how you will get. The next example, if you want to pass an n-dimensional, so how you can pass we have seen already, right? So you will give n_diamn equal to 5. This is how you will give the n-dimensional array. So here I am giving 5-dimensional and I am printing the shape. So you can expect the output. So you will get it as. So this is what. Then we can say that it is 5th element because the dimension here is 4 and you will add one element and add 1, that is 4 plus 1 is 5th element. You can say 5th dimension has 4 elements because it will be starting with 0, 0, 1, 2, 3, 4 like that we will count. So we can say that it is 5th dimension is having 4 elements. So this is what about the dimensional and numpy array shapes and copy, view, all these things. In this video, we are going to see about the methods of the arrays and how to create an array with the help of for loop and how to access. So we know that we can create with the help of lists also. But in the arrays, it will with the help of one variable, we can create number of elements in the with the help of variable like ARR1 equal to 1, 2, 3, 4, 5. Like that we can create. And also it will be storing in continuous locations, memory locations. So it is having very much efficiency. You know all this, right? So let us see with the help of a simple example, like we can to prove that we can also create array with the help of list. So this is a simple example. So here what I am doing here is, here I have created array equal to 1, 2, 3, 4, 5 and I have also created the string ARR1 equal to welcome to Conjugate created, and here I am creating an array using the list. So it is also possible to create array with the help of list, and I'm doing with the help of for loop. I'm accessing the values of the array for I in ARR. So whatever the values in ARR, you will get with the help of for loop. So let us run this program. Can you expect the output? Yes. Create array using array function. So we are having array already, the built-in module array, and we will import the built-in module and then we will use this. So here I have imported array, import array, and then I am initializing array, ARR equal to array dot array. So what is this array? Here this array is this one. Already we have imported this array, right? So I am using that array method I am using here. So with the I am passing the values, signed integers as well as I am passing. So print the new created array is and equal to. So here what I am doing here is I am printing the statement. The new created array is like that, and equal to, what is the end I'm printing? So for I in range of 0, 3, we know that what is this range is, right? So range of 0, 3, and then print array of I. So we are printing array of I, 0, 1, 2, 3, like that it will print. So range function will print from 0 to 3, and here for every iteration it will print one value from 0 to 3. Sorry, from 1 to 3, because we have initialized here 1, 2, 1, 2, 3, like that. So this is about the creation of the array. So the next thing is array created using Numpy methods. So what are the matrix with all the array with the 0? If you are given 3 by 4 matrix or 3 by 4 array, and you are accessing the method called np.zeros, then it will create all zeros, and np.empty. So here what does this empty method will do? All this we will see. So first let us see with the empty method, np.empty. Here I am passing the parameters or arguments as shape, dtype equal to float, order equal to C. I am passing these are the arguments. So what it will return is, it will return the array of given shape and then type with random values. With random values it will. So what is this order equal to C is? It is row major order. It will go with the row. And if you are giving here F, it is column major order. So by default it will go with row major order. If you give the C, or if you won't give, it will go with the row major order only. So here I am giving a simple example for numpy.empty. So let me go with this. So what I am doing here is I am importing numpy and I am creating ct.empty with the 2, dtype equal to int. So what it will give here is, so let us see the output, what it will show you, you can see. So let me write C. And see here, empty, dtype equal to int here I have given. Here dtype equal to int. Here I am passing one parameter, that means one order, single order. Here I am passing the matrix with 2 by 2 matrix. Here I am passing the matrix with 3 by 3 matrix. So we will run again and you can observe the difference. So you will get it as other number. So if you run again, you will get the other number. So this is how you will get. So whereas this is a 3 by 3 matrix. So this is how you will go with the empty method. Empty will initialize like that. Then coming to zeros. So if you are giving like zeros, import number as CT, and then I am giving here everything as zeros. So I will get for every matrix, that is for 2 by 2 matrix, for 3 by 3 matrix, and for first order matrix, every matrix I will get it as zeros, because I am using here CT dot zeros. Since I am using CT dot zeros, I will get every matrix with zeros. So let me run this program. So you will get, this is one single order matrix, 2 by 2 matrix, 3 by 3 matrix. Since I have given here 2 by 2, 3 by 3 and 2. So this is how you will go with the methods of empty and zero. So let us see some more things. So how can you reshape an array? So this reshaping an array we have already seen according to the concept points. Now we will see practical. So what is this reshaping array will do is, if the matrix is the original size of the matrix is same, that means the A matrix and the B matrix is same, then only you can reshape the array. So what is this? What it will take the parameters as? It will take array, comma shape, comma order equal. Here I am printing the original array. So arrange method, what it will give here is, I have used here 8. So it will give from 0 to 7. Like it will work as a similar like a range type. So array equal to ct dot arrange of 8, and here I am reshaping the array with 2 rows and 4 columns. And here I am arranging with reshape 4 rows and 2 columns. So you can see what it will happen. And finally I am reshaping with 2, 2, 2, that is 3D array. So here you can see what happened. So this is the original array. Since I have used here a range of 8, I got it from 0 to 7. And then I am reshaping the array with 2 rows and 4 columns. So you got it as 2 rows and 4 columns. And I'm using reshape 4, 2, that is 4 rows and 2 columns. You can see here. And this is a 3D array. You will be having 2, 2, 2. So you can see so 2, 2, 2. So this is how your array will be printed with reshaping matrix. So you are reshaping the original matrix with this kind of matrix, 2 by 4 matrix and 4 by 2 matrix and 3 by 3 matrix. Sorry, 3D array matrix like this. So this is how you can reshape. So here we have used the different methods like arrange method we have used. So what is this arrange method will do is, it will return evenly spaced values in a given interval. So here I did not mention, in the above example I did not mention any step size. So it is giving like in a consequent manner, like in a 0, 1, 2, 3, 4, 5, 6, 7, 8 like that. It is giving in a continuous manner, right? So if you give the step size, then it will skip. What is the use of the step size? We have already seen, right? So it will skip that values. So we will see with one example that also. So here I have given input numpy as ct and have given values. So ct dot arrange 4 dot reshape 2, 2 have given here. So here I am using 4. Here I am using 4, 10. That means from 4 to 10. Here I am using 4 to 20 with step size of 3. 3 means it will give us 2. So it will skip 2 values, right? We have seen in this. If you are giving the step size, then it will skip that values. Coming to the linspace. So what is this linspace? You should give the parameters like start, stop, num equal to 50. Num this is up to you how much you can give. You can, and then point equal to true. So these are the things you should mention. So if you want, what it will return is, it will return number spaces evenly with respect to the interval. Similar to arrange, but instead of step, we are using here sample number. So let us see with a simple example of this. So here I am using universal functions like sine and all. So you can see here. So here what I am doing here is ct.linspace. Here I am using 2, 3 and num equal to 5 I am using. So what is this? What it will give? You can see the output. So what is this linspace will do is, so here you can observe linspace what it is giving here. It is giving with 2.25 interval. The numbers you can see here 2, 2.25, 2.5, 2.75, 3 like this. That means 0.25 interval you are getting the linspace. And you can also evaluate sign function with 0, 2. Here I am using 0, 2 with the size of 10. That means, why I am given here 5 is to give the 5 values. 1, 2, 3, 4, 5 values I got. So here I have given 10. So I will get 10 values. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So it will give a value. It will take the values from here 0, 2 and it will give 10 values. Sign 0, sign 1, sign 2, sign 0.1, 0.2 like that. Order. If you want column major order, you will go with F, as we all know that. So this is the thing. Let us copy. So here I have given import numpy as ct and have initialized array equal to ct dot array. So 1, 2, 3, 4 I have initialized and I am using here flatten method. You will just see the same copy method. So some error I got, so I did not close here. So let us run again. So here you will get same 1, 2, 3, 4, 1, 2, 3, 4. This is what you will get. That means you will get the same copy of this flatten method. If you will go with row major or you will go with column major, it will give you the same like this. So it will copy into a single dimension. So you are having some more methods like empty like, identity, ones, one like, zeros, zeros like. So all this you can use. So according to the purpose, we will use these methods. These are all the methods we are having. BMAT, MAT, Wander. So what is this BMAT is? It will build a matrix according to the build a matrix object from a string, nested sequence or array. So this mat, what is this mat will do is it will interrupt the mat input as a matrix. Wander, generate a Wander matrix. So all this lower triangle of an array, TRIL. So here U, upper triangle of array, TRI, with one diagonal, it will give the diagonals as 0. An array with ones, and below the given diagonals and zeros elsewhere. So these are all you can use according to your purpose. So these are the things. So we have seen most of them, like zeros we have seen, arrange we have seen, array we have seen, copy we have seen in our previous video, in the previous video, copy, view, all these things. So this is about the array methods. So in this session we are going to see about a beautiful concept, that is iteration over arrays. So how the iteration will take place in the arrays and what are the things it will undergo. So let us see that. So iteration over arrays, we are having an object called numpy.nditr. With this nditr, the iteration is done. So it is already we know that if it is an iteration, we are having much efficiency and already numpy is undergoing with multi-dimensional elements, right? So it is also possible for having a multi-dimensional iterator and it is having good efficiency. So let us see with a simple example how the iteration is going on. So as I have told you that nditr is one of the objects which is used for iteration. So here what I have done is I'm importing the numpy as ct, alias name. I'm using the alias name as ct and I'm using ct.arrange of 12. So when I have called the arrange method, then it will come from like 0 to 11 elements will take place. Here I did not give any step count for the arrange. So it will come from 0 to 11. If I give the step, then it will skip the values like we have seen and slicing, right, in the same way. So here I am giving the reshape 3 rows with 4 columns. The original array, whatever the array it is coming, like from 0 to 11 elements it will take, and it will be occupied with 3 rows and 4 columns, and I have called the reshape method. And the modified array is 0. For the first iteration, it will take 0. For the second iteration, it will take 1. For the third iteration, it will take 2. Like that. For every iteration, it will give one number. So let us see the output. So this is how the output you will get. So the original array is 0 to 11 and the modified array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each and every iteration is giving one element to you. So this is how you can use the ndir. So for the iteration. So the next thing is we can also do the transpose of the array. So we know that array is occupying the continuous memory location. As it is occupying the continuous memory locations, it is easy to fetch the elements also, right? So even the transpose will also remain same because it is going with the for loop. So here what I did is, here for the same program, for this the previous program, I have used b equal to a dot t. We know that about this t, right? Transposing. So t is the built-in method, and it will it will give you the transpose of the original array. So here I have given the b. So it will give you the same output as the previous thing, because again it is going with ndir. So this is how. So this is the original array. This is a modified array. So even though it is transposed, it is giving the same thing. So this is about the transposing. So controlling, how to control the iteration order. So here I am controlling the order with, if you want to occupy the same order, if you don't want to change all the things like row major order, how it will do order equal to C, and how it is order equal to F. So we will see that. So let us see this example with order equal to C. So it will take one of the parameter called as order equal to C. It will go with row major order. So when it is going with the row order, you will see like the same output which we have seen in the previous example. So it will walk around the rows. So here what I have given. So for the same example here, I have given order equal to C. So you can see the output like this. So 0, 1, 2, 3. First it will go with 0 and 1 and 2, 3 according to the row wise like this. 0, 1, 2, 3. Next 4, 5, 6, 7. Next 8, 9, 10, 11. So in this way it will go. So if you are changing with the column major order, so you can give here as F. So if you are giving with the column major order, according to the column it will change. So you can see here. So 0, 4, 8, then 1, 5, 9, then 2, 6, 10, then 3, 7, 11. In this way it will occupy. So next one is modifying array values. So how to modify the array values? So we are having a flag called OP flag. So what is this OP flag will do is, as we have seen in the file operations, like we can change, we can read, write, all the operations we can do for the files, right? In the similar way here also we can read, write the files, but by default you are having that read only. So read flag. So here we are giving read write. So it will read the array as well as it will write the array. So for the modification, what I am doing here is I am multiplying the original array with the 5. That means I am multiplying 5 times the original array. That's what I am doing. 5 times. Modified array will be 5 times the original array. So let us see the output, what it will display for us. So this is the original array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is taking the 5 times. 0 into 5 is 0, 1 into 5 is 5, and 2 into 5 is 10, 3 into 5 is 15. In this way, it is taking 5 times the modified array. That means here it is undergoing read. The original array is reading, as well as it is writing also. It is doing 5 times and we are getting the output. So this is what about read and write. So we can also give OP underscore flag is the parameter. So this is how you can modify the values. So we can also modify, like we can also use external loop. So this ndarray class constructor, what it will take? It will take the flags parameter, which can take the following values. These are the values will accept. So it will take external loop. So what does this external loop will do is, it will convert it into one-dimensional arrays. Whatever the values you are giving, instead of converting it to zero-dimensional arrays, it will convert it into one-dimensional array. Whereas C index, F index, example, so that it will be better understood. So let us copy this. So here I am inputting. So here I am inputting the numpy, and I'm printing the original array as well as I'm printing the modified array. So what I'm doing here is I'm giving the extra parameter as flag equal to external loop, order equal to C. So we know that flag equal to external loop means it will give in one-dimensional array. So I have given order equal to C. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see the one-dimensional array over here. So this is how you will get. So if you are doing here order equal to F. So what is order equal to F? It is column major order, right? So for the column major order, what you are getting? 0, 4, 8, 1, 5, 9, 2, 6, 10, 3, 7, 11. This is about the column major order. So this is the thing which will go with the external loop. So whereas the next thing is F index. So what does this F index will do? F index will go with the column major order. So how does the column major order will print? So let us see this. So here I have given for the column major order it equal to ct dot nditr, and then flag equal to F index. So flag I have given as F index, and here I am checking the condition. Why? If it is not finished, it dot finished is not, then I am printing the values here. So what values I will get? Whatever the first value I will get here is 0, and then within angular braces I will get 0. So because I am printing the first value, then it dot index end equal to space. Again it dot next, that means the next value I will get. So the next value is it of 1. So it will be 1. Next value is 2. Next value is 3. Next value is 4. Next value is 5. And then next value is, till 5 only, because here range of 6 I have given. So let us see the output what it will give. So since I have given here that array index is 0, it will print with the first value. So you can see here 0, 0, 1, 2, 2, 4, 3, 1, 4, 3, 5. This is about F index. And coming to the broadcasting iteration. So what is this broadcasting iteration is? So we know that when two arrays are broadcastable, then we can combine ndir object and it is able to iterate upon them concurrently. That means if we are having, for example, if we are having an array A with 3x4 matrix, 3x4 dimension, and array B with 3x4, 1x4 dimension, it will iterate upon the type of that which is used. Array B is broadcast to array A. Like depending on the size, it will be broadcasted. So how it is broadcasting? So let us see with this example over here. So this is the example which I want to show you, the broadcasting. So here I have given for the first array 3, 4 to reshape, and have given a range of 12. That means it will give with 0 to 11. And then modified array I have given x, y. So both arrays I have given A array and B array. Here for the A array I have used reshape 3, 4, 3 rows, 4 columns with 12. That means 0 to 11 it will occupy with 3 rows and 4 columns. And the next array I have given as 5, 6, 7, 8 with int values. So this is the second array. So here what I am doing for x, y, that means for A, B, here indirectly I am using A, is the second array, and the modified array is 0 and 5. So we are accessing first element of A array and first element of B array. 1 and 6, 2 and 7, 3 and 8, again 4 and 5, and 5 and 6, 6 and 7, 7 and 11, in this, 7 and 8. In this table says the values for broadcasting. So it is broadcasting the array B like this. Array A and array B, it is broadcasting in this manner. So this is how about the iteration process and broadcasting process undergoes in Numpy. So in this video we are going to see about binary operations in Python. So when we encounter that it is binary operations, we should get into our mind that the binary values will be existing, like binary values of 2 or any numbers. For any number, the binary values will be coming. So the binary operations will be performed bit by bit operation. So for every single bit, it is going to perform. The first thing is we are having different operations, that is AND operation, OR operation, XOR, invert, packing bits, and also unpacking. So what is an AND operation in bitwise or binary operation? So when the two conditions, like when it is 1 and 1, when both the conditions are true, we know that 1 indicates it is true, 0 indicates it is false, right? When both the conditions are true, then what do you say? Then the resultant will be true. If even one condition is false, like 1, 0, then the resultant will be false. If both the conditions are true, then only the resultant value will be true. This is what bitwise AND. So when it is coming to the OR, so I will explain the next thing in a while. OR. So let us go with the AND, bitwise AND. So let us execute this program. So we know how to denote the numbers with binary numbers, right? So here I have given input num1 equal to 1 0 and num2 equal to 1 1. So here I am printing the value, print bitwise of 1 0 and 1 1 is like that. I am printing. So let me run this program again. So you will get the resultant value as 1 0 because it is 1 0 and 1 1. So 0 and 1. So both the conditions are, one of the condition is false. So you will get 0. So here both the conditions are true. 1 and 1. So you will get 1. So if I change this to 1, so what can you expect? So you can expect 1 1, right? So yes, it is. So this is what about bitwise AND. So if I give here both the values are zeros, then you can expect both the values are zeros like this. So next is bitwise AND. So we can also do with the numbers. So in arrays, so like arrays we can do. So when we are passing the arrays, what it will do? First it will convert to binary operations, binary values. First it will convert to binary values, then only it will perform the addition or whatever we are doing here. So first this value will be converted to 8, 1, 25 will be converted to binary values. So the binary value of 2 is 1 0. So the binary value of 1 is 1 1. So what you will get? 1 0 and 1 1. So just now we have seen. So like that it will convert and it will give you the answer again as the decimal number like this. It will internally it will convert and then it will give you as the values. If any of the condition is true, like 1 0, then we will get it as 1. The resultant will be 1. 1 plus 0, you will get it as 1. Even it is 1 1. So any of the conditions is true, then the resultant would be true. here there is no conditions, like if both the conditions are true, then it will not be, it is true, not like that. So if any of the condition is true, then the resultant value will be true. So let us see here. So here both the conditions, like 0 and 1. So here one condition is false and the other condition is true. So the next one is 1 and 1. Here both the conditions are true, then you will get it as 1. So you can expect the output as 1, 1. So this is what the output. So for the bitwise OR, so here I am using bitwise OR. If you want to use AND, you will use AND. If you want to use XOR, or if you will use XOR here. So that is what we can use. So this is about bitwise OR. So let us see with other example here. Here for the same example, for the above example which is in the numbers, decimal numbers, here I am using the decimal numbers. It will convert to binary values here as well, and then you will perform the bitwise OR for that binary values, and then you will get the resultant value in the decimal value. Like for the previous program, you will get something, right? So for the OR you will 1, then only you will get as true. If it is 1, 0, then you will get the output as 1, and if it is 0, 1, you will get the output as 1. In the remaining cases, like if both the conditions are true, then you will get the 0 result. If both the conditions are false, then you will get false. So this is about in XOR. So if one of the conditions is true, then it is true. And if both the conditions are true, or if both the conditions are false, then the resultant will be false. So let us see this. We will see with the help of example. So here I am going to paste a code. So let me run this program. So you know that if it is any of the conditions is true, if both the conditions are true, or if both the conditions are false, then you will get it as 0, right? So here one of the condition is false and one of the condition is true. So what can you expect the output? So this will be true, and if it is here it is 0 and 1, right? So you will get the resultant as 1. So you got it as 1 before it is 0. So this is how you will do with the bitwise XOR. So next thing is complemented, like it will get it as 2's complement. So what is 2's complement? How can you perform the 2's complement? So for example, I am going to give an example. So the binary number of 7 is 111. So if you want to do the 2's complement of this number, how you will do? So first you will convert this number into 1's complement. So how can you convert this number into 1's complement is, you will revert the numbers. Like if it is 1, you will write it as zeros. And then you will add 1 to this number. So you will just add 1 to this number. Then it will become the 2's complement. So now you will do the binary OR operation over here. Binary OR. So you will get 0 plus 1 is 1. So when it is 0 and 1, you will get 1. And then before that you are having zeros. So you will get the 2's complement of 7 is 1, like this. So this is the 1's complement. And when you are adding 1's complement with 1, then you will get the 2's complement. So this is about the 2's complement. So when you are reverting the signed integers, or signed numbers, then you will get, when it will perform the 2's complement, then you can get the value. So now let us see the program, how to implement this invert. So I'll go with this. So with using the invert method here, ct dot invert, I'm going to ct dot invert method, so to invert. So you can have a look here, and I'm using here d type equal to ct dot int 8. So we have talked about this d type, what is this d type, right, in our previous videos. So here I'm using this. So you can see the output, how the inversion is going. So here you will get the inversion as minus 14. Like if it is positive number, you will get it as minus 14. So here I have given here as 10. So you will get it as minus 11. This is how you will get. So if we pass the unsigned integer u in 8. So in this case, what you will get it as? So you will get the 2's complement of this number. 2's complex thing, left shift. So this is also one of the operation of binary operation. So if you don't know the method how to do the left shift, you can simply remember that you can power the things like 5 multiply. You can multiply 5 multiply 2 power 2, or whatever the numbers we are giving, you will multiply with the power of 2 power something. So actually the concept behind this left shift is you will append the zeros at the right of that, so that it will shift to the left side. When you are padding in the left side, then it will get to the when you are padding in the right side, it will get to the left side. So you will see with the help of a simple program. If you don't know the process, you should remember this thing. You will, when it is left shift, you will multiply the things. So here I have given as bit shift is 2 and the number is 5. Bit shift is 2 and the number is 5. So what you will do here is, as I have told you that 5 multiply with 2 power 2. Here you will raise with the power of 2. So since I have given here bit shift is 2 power 2, then you will multiply 5 into 2 power 2. If it is 3, then you will go with 2 power 3. So see here. So 2 power 2 is 4, and when it is multiplied with 5, you will get it as 20. So let me right shift. You will divide. You will divide the numbers, and the resultant will be the quotient. After left shifting, you will get it as quotient. See, when 20 is divided with 3, you will get as 2 power 3. So here you will do when 20 is divided with. So I will show here. When you are going to divide here 20 divided with 2 power 2. You will get it as 5. So in the similar way, here what we are doing here is, here I have 3 over here. The number of bit shift is 3. So when it is raised to the power 2 raised to the power of 3, then you will get it as 8. Right? So 20 divided with 8. So how many times it will go? 2 times. So since it is 8 to 16, so the quotient is 2 over here. So after left shifting the 2 bits, you will get the answer is 2. When it is, after right shifting. So since I have changed here, but I did not change the print statement. You can change over here. Just I have changed the method. It is right shift here. So in the right shift, just remember that in the right shift, what you will do, you will just divide the numbers, whereas in the left shift, you will multiply the numbers. So this is how you will do. So here you will divide, and then here you will multiply. So actually, here the process behind here is you will have binary numbers. So when you don't know the numbers, like it is very easy to remember the values. There will be an easy concept like how to remember the binary values, but here we will see with the help of a method called binary underscore REPR, binary underscore REPR. So this is a binary representation. Here I am accessing for binary representation value is 10. I am asking. So the binary representation value for 10 is 1010. with this method we can represent the binary values. So you can see the binary value of 1. We know the binary value of 1 is 0, 1. So you can see the binary value of 2 is 1, 0. So this is how you can represent the value of the binary values. And then coming to the next thing is packing bits and unpacking bits. See, what is this packing bits and unpacking bits is? You just get the concept like how you are packing when you are doing something parcel. How you will pack? You will wrap everything. You will wrap the content. Then you will send the parcel, right? So in the same way here also, what you will do here packing is, actually I have given here one of the arrays here. So np.array I have given the array over here and I represented the bits. So when I am accessing the values, like when we are trying to access these values, it will be appended with 5. So like that it will be appended, and then you will get the values as the appended values. Sorry, without this I should run. So now you will get the answer. So this is 16064 and 192, 32. After appending the values, you will be getting the binary numbers. Sorry, the decimal numbers of these numbers. So when you are unpacking the bits, what you will get? So you will give the numbers like the actual decimal numbers. Then it will unpack the bits and it will give it in the binary numbers. So now here I have given as 2, 7, 23. So it will unpack by using unpacked bits. By using the method called unpacked bits, then it will give you the numbers of the binary numbers. So you can see the binary numbers of this. For 2 it is 10, and for 7 it is 111, and for 23 it is 10, 111. This is how you will get the packed bits and unpacked bits. So in this session we have seen about bitwise operations, that is binary operations, that is AND, OR, XOR, packed bits, unpacked bits, and invert, completing the invert. So that's all for this video. So in this session we are going to see about mathematical functions. So like what are the mathematical functions? Like trigonometric, we are going to have trigonometric functions and arithmetic functions. So like that we will see all those things. Coming to the trigonometric functions. So what are the trigonometric functions? We have like sine, cos, tan, cosec, secant, all these things we are having, right? So how these new trigonometric functions can be implemented with the help of Numpy? Let us see into that. So the basic syntax of this Numpy using sine is for the trigonometric function. This is the syntax. So we are going to use numpy.sine of x. Here x is the array element, and the comma out equal to u-fun. So u-fun is a universal function, that is sine function. So we are going to use that. So let us see that. So let me take this example. So already we have seen this example, but as we are seeing now the trigonometric functions, we are going to see it again. So let me paste it here. So here I have used np.sine. Since I am using sine function, I am using the sine value. So here I have used math.py. So I have also imported the math module, and I imported numpy module as np with the alias name. And what I am doing here is math.py by 2. That means I am dividing the pi value with 2. Here I am dividing the pi value with 3. Here I am displaying the pi value, and after that I am assigning with the sign np.sine of all this math.py by 2. Keep on divided with 2, you will get this value, and divided with 3, np.py actual value, you will get like this. So when you are going with the sign values, you will get the sign values of this. So if you want to go with the cos values, so what you will do? You will just change the function as cos here. So like cos or tan or which function you want, you will go with this. So you will according to that function it will change the values. So again it will compute like 0 math.pi by 2, it will compute the value of pi by 2 and it will compute the value of pi by 3. Then the cos value will be applied for this in array. So these are the cos values. Since I have changed here cos, np.cos. So this is how you can go with the cos, sine or tan or whatever the values you want. So for the cos also you will go with the same x comma out equal to u1 equal to u1 comma cos. So this is how you will. So there are some more functions like tan, arc sine. Arc sine is the inverse of sine, and arc cos, tan, arc tan 2. So this is about the tangent with the tangent like then this is the degrees, radians to degrees it will convert, rad to degree. Next degrees to radians. Then this is a hypotenuse. Given the legs of a rectangle, then it will become the hypotenuse. That means if you are giving the two sides of the triangle, then it will give the hypotenuse value. And then this is the unwrap. So these are the different functions you are having with the help of trigonometric function. Coming to the hyperbolic functions, we are having hyperbolic functions like sin h, cos h, tan h, all these values. So this is also having the same syntax like numpy dot sin h of x comma out equal to u sine. So here I have given a simple example for that. So this will be equivalent to 1 by 2 into np dot exponential value of x minus exponent of minus x, or you can also do with minus 1j into np dot sine 1j into x. X is the value which we are giving over there. So let us see the example with this. So same example we will use here npy dot sin h for the same previous example. So here just we will use npy dot sin h, whatever the value you want you will get here, sin h or cos h, whichever you want you will go with that hyperbolic functions. So these are the values of hyperbolic function 0, 2, 2.3 and 1.24, 11.54. This is how you will get. So if you want cos h, you will change with cos h. So these are the different hyperbolic functions, and some more hyperbolic functions also you have like tan h, arc sin h, arc cos h, arc sin h. These are the reverse of the sine, cos and tan, inverse. So next coming to the functions for rounding. So we can also round the values. Like here we are having two functions, which is around function is the first one, and for this what we will give is array decimal equal to 0, out equal to none. So let us see with this example. So in this example, what you will do here is it will go with the round values. Like if you are giving 1.56 like that, so it will take the nearest rounded value. So here I have used the method called a function called np dot around. You can see here around in everything I have used. So I have given the input values as 0.5, 1.5, 2.5, 3.5 here, and the other array I have given the values as 0.53, 1.54 and 0.771, and for the next array I have given with the decimals 0.5538 like this, and 1.33354 and 0.71445 like this I have given. So in this around method, around function, you will go with the rounded values. So you can see here 0.5, 1.5, 2.5 is changing to 0, 1.5 is changing to 2, 2.5 is changing to 2, and 3.5 is changing to 4, 4.5 to 4, and 10.1 to 10 like this. So if you are going with the decimals here, so 0.5538 is changing to 0.554. So since I have given 3 in the decimal values here, I have given here 3, decimals equal to 3. So you will get 3 decimal points over here, 1.334 and like this. So this is how you will get 1.334. It will turn to 3 decimal values. So this is how you will get with the round function. Whereas in the round function, here you will give, here also you can round the values similar to that. So you can see here. So with this example I am going to show you. So here you will get the decimal values. Let me make it down. So here in the same for the same function, for the same program I am using here now round. Same value, same. You can see the output. So 0.5 will be changed to some value. And next point, here also have used the decimals equal to 3. So it will also turn the rounded values to be 3. Here 0.531, 0.54, different values I have given as in the previous example. So you can see the outputs. So 0.5 is changed to 0, 1.5 is changed to 2, 2.5 is changed to 2.5 is changed to 2, 3.5 is changed to 4. Like this. Here with the help of decimal values, 0.5538 is changed to 0.554 and 1.3354, 1.334. This is how it is changed. So we will see some more functions. Like we are also having some more functions like array. It will run nearest to integers to 0 towards 0, and fixed will be towards 0, nearest 0. Float, C, truncate will be truncates the decimals like that. So this is how about the things like the sin h and cos h we have seen around and round, right? So for the next thing we are going to see about exponents and logarithmic functions. So what does this exponent and logarithmic functions will do is, so the basic syntax of exponent is, this is how you will write. You will pass the array and out equal to none, where equal to true, casting equal to same kind, order, and d type you will provide here which type it is, whether it is int or uint or like that. So let us see this example. So the exponent value, the exponent function, how it will look. So here I have given np.exp. So see the output of this np.exp. So the array is, the input array is 135. So what does this exponent will do? The exponent function will do, it will give the exponential values of all these 1, 3, 5. So these are the values, e values. E raised to the power of 1, you will get 2.73. E raised to the power of 3, you will get 20.03. You can check all these values. So this is about the exponential values. Coming to the logarithmic values. So you can use here in place of exp, we will use log, and whatever the log values we want, for what the log values we want, we will change with that. And also we can use the powers for that log values as well. So let us see this example. So I'm putting here and then I'm using the log values here, np.log of Unary. So I'm passing the values as 1, 3, 5, 2 power 8. So this is how these are the log values of this. So log 1 is 0, log 3 is 1.098, logarithmic of 5 is 1.60. So np.log 4 power 4 is log 5.5. This is how you are getting the values. So you can see here 4 power 4 and 2 power 8. This is how you will get the values of logarithmics. So next, apart from those functions, we are also having exp m1, exp2, log base 10, log base 2, log 1p, log add x2. So these are the different functions. Next, coming to the arithmetic functions, you are having the arithmetic functions as reciprocal. So for the reciprocal, you know that it is if you are giving 2 as a number, so you will get the reciprocal as 1 by 2. So the value of 1 by 2 is 0.5, right? So the reciprocal, by using np.reciprocal, you will get the values like this. 1 by 2 is equal to 0.5. So if you are giving here 4, you can expect the output as 2, right? 1 by 4, sorry, 0.25. Yeah, 0.25. So this is how you will get the values. And also you can get and also we are having some more functions like divide. So you are going to give 2 arrays here. So let us see this. You are going to give 2 arrays. It will divide those arrays with 1 by 1. Then you are going to get the values. So here 2 by 2, 27 by 3. So this is how you will divide. You will give the input arrays over here and you will get the output arrays like 2 by 2 is 1, 27 by 3 is 9, 2 by 4 is 0.5. So here what you are using np.divide like this. So you can also use different functions like add, positive, negative, multiply, power, subtract, true divide, floor divide, float forward, mod, reminder, give mode. All these functions you can use according to our requirement. So next thing is complex real numbers. So what is this complex real numbers will do is it will check whether it is the complex number or it will check whether it is real number or not. If it is real, then you will get as true. If it is like complex number, then you will get it as false. So let us see that. So complex number is of the format of a plus bj form, right? So yes, so this is a complex number, right? So you are getting as a false. And oj you got it as true, and per 1 you got it as true. This is a real part. So this is how you are getting. So these are the different things like complex numbers you have seen. So next thing is conjugate. So what is this conjugate value is, if you are giving the value as a plus ij, so if you are giving the complex number as a plus ij, the conjugate value of a plus ij is a minus ij. So it will give the conjugate value. So here I am giving the complex number as 2 plus 4j, and I'm using the complex function, sorry, conjugate function as np.conj. So it will give the conjugate value as 2 minus 4j. And here I am using 5 minus 8j. It will give as 5 plus 8j. This is what the conjugated values. So you use this conjugated values and complex values while you are working with the complex numbers. So next, special functions. So you are having different special functions like cube root, square root, clipping, all this. So you will see this. So we can also get the cube root of the numbers. So if you want to get the cube root, you are going to use the function called cbrt. np.cbrt. Here I am using np.cbrt. So I will get the value of cube root of 1 is like 10. Cube root of array 1. Here I got array 1. The value of 1 is 1, and cube root of 27,000 is so 30, and cube root of 64 is 4. So this is how I will get the values of cube root. So here I have given the other array 0 to 4 and minus 1 to 8. So these are the different values of the cube root. So we can also use square root. We can also use different functions we are having. So we will see those. So the next thing is clip. What does this clip will do is, we can set the interval like max interval, max value and minimum value. So with this maximum and minimum value, the clip value will be, the clip function will be worth. So here the minimum value I have given as 2 and the maximum value I have given as 6. So whenever it is seeing the less than value of 2, then it will give as 2. Whenever it is seeing more than the value of 6, then it will give, then the output will be 6. So you can see here. So 1 is less than 2. So you will be getting 2. So here I have set the minimum value as 2. When you are seeing the maximum value like 7 and 8 greater than 6, so you will get the values as 6 and 6 like this.
So this is about the clip function. So we are also having different functions like square root function, square, absolute, fab, sine, interrupt, maximum value, minimum value, and real if close, none, not a number. So if it is not a number, it will replace with 0, and heavy sign. So these are the different functions, and these are the different functions which we are going to use in NumPy. So that's all for this video. So in today's video, we are going to see about string operations. So what are the string operations we have? Like if you want to convert the capital letters to lowercase letters, uppercase letters to lowercase letters, or vice versa, lowercase letters to uppercase letters, or if you want to compare the two strings, or if you want to split the strings, what you will do? All these things we will see in today's session. So if you want to convert the uppercase characters to lowercase characters, you will use a function called numpy.lower. With this, it will convert the uppercase characters to lowercase characters. So the important thing which you should remember here is, whatever the uppercase characters you are having, it should be there in the parentheses here, like this, np.char.lower. Like this, you should pass the uppercase characters. It's okay if you are passing the lowercase characters also, it will return the same string because there is nothing to convert, right? So here I passed the uppercase characters, so I got it in lowercase format, like this. So next thing is split. How to split? How to separate the things like words. So here I am splitting. So the name itself indicates that splitting means separating, right? So with the help of SCP, you will separate the separate the words like this. So see here, I am using char.split here. So with the split method or with the split function, we will separate the words like this. So this is about the splitting. Coming to the next thing is joining. How you will join? So with the help of a separator, you can join the words or characters. Here we will see with the help of a separator characters. So here I am using the separator as hyphen. So with each and every character, each and every letter will be joined with the help of a separator. See here, you can see C hyphen O, D hyphen, I hyphen, like this. So here I have used two separators like hyphen as well as colon. So here you can see C hyphen O hyphen D hyphen, like this, and for the you can see like this. So this is about join. So you are also having different function according to the requirement. You will choose the functions like strip, capitalize, center, decode, encode, adjust, adjust. We have all these seen in the Python tutorial, string functions, right? So you can have a look over there. So the next thing is NumPy string information. So what is the string information will do? Like it will count the occurrences. Let us see how it will count. So here I have used the function called as char.count, np.char.count. So with the help of count, it will count the substrings or the strings, how many number of times, like number of occurrences. So this is one occurrence, this is the other occurrence for coding. So here we can see the substring coding here. Here also we can see the substring. So you will get 1 over here and 1 over here, and you will get 0 over here because that is not a coding. And here I am checking the substring FO. So here it is. So I will get 1 over here and the remaining I will get 0. So you can have a look at the output here. So as I have encountered this coding here, so I got 1 and 0 over here and 1 over here. For the FO I got 1 in the middle. So let me give S here. So it will be the full string. So again I got the same thing 1 0 because I have encountered codings here and codings here, like that. It will check. So count will check how many times the occurrences of this word is there, like that. So here and here. So next thing is find. R find. So what does this R find will do is, it will find whether you are having a string or a substring while passing. So here, let me do this. So here I am passing a comma coding. So a is a variable which will hold this words, right? So it will check coding. So let me write here yes, so that it will become the full string. So coding, it will check whether it is there or not. Find, it will find. If it is yes, then it will return something. So see here. So here I am passing the substring fo. So whenever we have encountered, whenever it is fine, then it will return 0. Whenever it is not fine, then it will return -1, like this. So here I am seeing codings, yes, true, so 0. Here I did not see codings, false, so I got -1, codings 0. So in the next string I am passing F4 for the substring. So it will also check the substrings also. So F4, yes, it is true. So I am getting the output like this. So -1 is absent and 0 is presence. So next thing is numeric. So it will check whether the one which we are passing is numeric or not. If it is numeric, it will return true. If it is non-numeric, it will return false. So for that I am using is numeric. So this is a string and this is also the string. But passing the string with numbers. So let us see what it will give. It is giving false and false. And let me pass the number over here. You can expect the output now. So it is a number. So it will return true. Now it will return true. So this is what is numeric. Is numeric will check whether it is having numbers or not. So the remaining functions like find, index, is alpha, is decimal, digit, lower, is space. So you can work on these things. So next thing is string comparison. So what does the string comparison will do is it will check each and every character. It will check each and every character whether it is matching or not. If it is matching, it will return true. If it is not, it will return false. So you got it as false because I am passing codings and for. I am using char dot e equal. So codings and for both are not equal. So I got it as false. So let me write here for. So both the things are same. So I should get true. Yes, I got it as true. This is how you will compare the two strings. So next one is not equal. So what is this not equal will do is it will check whether it is equal or not equal. So it will check here also it will check every character. It is equal or not equal. So I will use here not underscore equal. So codings and for. So is it two things are equal? No. So I will get it as false. Sorry, true. Because here we are using not equal. If it is equal, then we will get false. So not equal is opposite to equal. So we will get true like this. So this is our not equal. So next thing is greater. So what does this greater will do is it will compare the two strings character by character. So first value, what is the first value? What is the second value? Character by character it will compare and then it will return. So if the string 1 is greater than string 2, then we will get the output as true. Otherwise we will get the output as false. So let us see with the single character. So here I am using C and F. So if C is greater than F, C is small, right? So we are getting false. So let us swap these two. So I will give F here and I will give C here. So now F is greater. So I got it as true like this. So So string, if string 1 is greater than string 2, then you will get true. Otherwise, you will get false with this greater. So here what you are checking is it greater than or not you are checking. So the remaining thing is like greater equal, less, all these things you can check. So if it is greater than equal, you will, the string 1 is greater than or equal to or not, you will check less equal, you will check if it is less than or equal to. So it will, numpy dot less will check whether it is less than or not. So these are the things we have studied, like in the string comparisons and string operation. In the string operations, we can go with the lower, upper, all these things. So in the string comparison, greater, lesser, and in the string information, we can go with count. All these things we have studied. So that's all for this video. So in today's session, we are going to see about numpy, sorting, searching, counting, how to do searching, sorting and counting, all these things we will see. So as we know that sorting means is arranging in the order. For example, if we are having the alphabets like B, A, D, E, like that. So if we are going under the sorting method, so what you will do, it will come as A, B, C, D, E, like that. In a particular order, it will be arranged. So that is what sorting, whereas searching means finding things, as you know, and counting means counting. So let us see how we will implement with the help of numpy. So with the help of numpy, the sort function will sort the array numbers here. So let us see how it will sort. So this is a piece of program, piece of code. So how it will implement, we will see. So here what I did is a equal to np.array. So I am initializing array to a variable, and the array values are like 12, 15 and 10, 1. And here I am doing the sorting, np.sort with sort function, and I am using the variable called a here, and axis equal to 0. What is this axis equal to 0? You already know that, right? So this ARR1. So whatever it is sorting, it will be stored in ARR1, and it will print the statement like along first axis ARR1. So it will print this statement, and after that, here what I am doing, I am sorting the along with the last axis. So what is the last axis? A equal to np.array 10, 15, 12, 1, 10, 15 and 12, 1. And array2 equal to np.sort. So here I am giving the other array, and it is np.sort, and I am giving axis equal to -1, that is in the reverse order. So and I am printing along first axis ARR2. Finally, what I am doing here is np.array and 12, 15, 10, 1, same array I am giving here, and you can see here ARR1 equal to np.sort, axis equal to none. So here I am giving axis is none. So whereas here I have given axis equal to 0, here I have given axis equal to -1, and I am printing the statement here finally. So you can see the output over here. How you are getting. So along with the first axis, you can see along with the first axis what we are doing. We are giving 10, 1 and 12, 15. Along with the first axis, I am giving 10, 1 and 12, 15. This is the input what we have given, and along with the first axis, I have done the sorted here. It is 10, 15 and 1, 12. So you can have a look here. So here I have initialized 12, 15 and 10, 1, and I have sorted this. A, axis equal to 0. So according to axis equal to 0, you will get 10, 1 and 12, 15. And along with the first axis, you are giving as ARR1. So whatever it is there, according to the sorted manner, it will be assigned here 10, 15 and 1, 12. After that, I am doing here along with the first axis, along with the none axis, what I am printing here is none axis is ARR1. So it will be 1, 10, 12, 15. So this is what array 1, what we have done with the none axis, and along with the
array 2. So this is what you will get. Here 2 is sorted according to the one which we have given. So this is about sorting. And coming to the argument sorting. So in the arg sort, what you will do here is, this is what arg sort. So here in the arg sort, what you will get here is according to the indices. According to the indices you will sort. So according you will get with the indices number as well. So what is indices? So you will have the index for each and every array, right? So array will start with index number 0, right? So in that manner you will get according to, even with the help of, even with indices also you will get. So here what I am doing here is, I am initializing the array np.array with the values here, and I am printing the original array, and here I am using np.argsort. So here I am sorting with the help of indices, sorted indices of original array. Here I am sorting here, and it's equal to np.0. Here I am using np.0 with the length, and dtype equal to int. Here I am giving int as well. So here I am giving the for loop for I in range 0 and length of b. So length of b here you will get, and c of, I am initializing c of I equal to a of b of I. A of b of I. So finally I will get the sorted array with c. So you can see the output. So this is the output which you have got. So original array we have given here is 917436 like this, and sorted array here what about according to the indices. So you can see the indices 2154 2154630. So this is the highest one, right? So this index value is 0, 1, 2, 3, 4 like this. So 0 will go to the last because it is highest number, and you can see the 1 here. So the index of 1 is 0, 1, 2 here. So you are getting 2 over here, and 9 is last. So this is how you will get with the help of indices. Finally, you are getting the sorted array here with the help of for loop. Sorted array here you are getting. So this is what about sorting with indices. Next, coming to the let's sort. So you have seen already, like in other subjects like lexicons, tokens, all these things you have seen in compilers and operating systems also. Like compiler mainly you will see compiler why you are designing the compiler, right? So lexicon, lexemes, all these are simple terms. So how you will sort? So let's sort, what it will do here is, it will be sorting with the help of keys. Using the sequence keys, it will sort. So how it will sort, let us see this. So what are the keys and how it will sort, we will see. So here we are using zip function as well. So we have seen already zip, what is zip, right? So here I am using np.array for the first column and for the second column. Thus I have initialized, and I am printing column A and column B, and here I am using for loop for I comma j in z comma ab. That means 9 comma 4 3 comma 6 like this it will come, because it is accessing one element from A and one element from B, since we have used A comma B here. And I am printing I and j. I am printing I and j, 9 and 4, 3 and 6 like that I am printing. And I am using here let's sort, it will be sorted with the help of indices as well. So it will take the two arrays and it will sort with the help of indices, and it will give you the indices as well here. So this is output. So as we have expected, A for A comma B for I and j. So here you are getting column A and column B values 9, 4, 3, 6, 1, 9 like this, and sorted indices you are getting as 2, 3, 1. 5, 4, 6, 0. This is what the sorted indices. So you can see the indices here. So this is a 2 value and this is a 0 value like that. So this is about let's sort. This is about the let's sort, and the remaining functions according to your requirement you will use like numpy.nd.array.sort. So numpy.msort, sort complex partition, R partition, all these things you can use for sorting. Whereas for searching, so this is what for searching, numpy.rmax. So what it will return is, it will return the maximum element of an array.
So in the given array, what is the maximum element according to the row and according to the column? It will return the maximum element as we are using argmax. So let's see the code of this. So what I have initialized here is coding.range of 12. So as I have given a range of 12, so you can expect the values from 0 to 11, and I'm here using reshape 3, 4. So it will be 3 rows and 4 columns. Here I'm printing input array is array. That means this array you will print here. And for the next line, here I'm printing the maximum element as I'm using the max function here, argmax of array. So from this, it will print the maximum element, and then indices of maximum element, like from coding from argmax of 0. So here you will get according to the row and column. So you can see the output now. So this is our output. So the array which we have given is with the help of arrange function of arrange of 12, you got it at 0 to 11, and the maximum element from here is 11, and whereas the indices of maximum element in here you are getting the indices of the maximum element according to the row. So here you will get as 2, 2, 2, 2 because we are having this is the maximum number because 0, 1, 2, 0, 1, 2, 0, 1, 2 like this. According to the column wise, according to the row wise, you will get the indices 0, 1, 2, and so here you can observe here. This is the 0 element, this is the first element, and this is the second element. So all these are highest. So you are getting here 2, 2, 2, 2. And coming to the next one. So you are here you are getting 3 and 3 and 3 like this. So you can see here this is the 0th element, first element, second element, and third element. So this is how you are getting 3, 3, 3. 0, 1, 2 and 0, 1, 2, 3 like this. So this is how you are getting you are working with argmax. Coming to the NaN argmax, NaN is nothing but not a number. So you will see the maximum element of the array in particular axis. It is ignoring that number and it is checking what is the maximum element from your array. So it is checking the NaN number. NaN, it will check the NaN also. So let us see here. So here I am importing. Let me do this. So here what I am doing here is I am using r.nan. So here coding equal to array equal to coding dot nan. Here I am using, and I am passing the values as 4, 2, 3, 1, and I am printing the input array whatever I am giving here. It will print here. And I am passing the values as nan, 4, 1, 3, and I am printing the maximum element of this array, and I am printing this input array 2. And printing the next according to the indices of axis 1. I'm printing this. So I got the error here. Let me check the indentation. After running this, I got the output as C here. So input array 1. So what is input array 1? See here, you can observe here input array 1 we are passing here as nan, 4, 2, 3, 1. So this is what you are passing. And indices of max in array. What is the indices of the max in array? It is 1. And the next input array here you are passing here is nan, 4, 1, 3. Nan, 4, 1, 3. And the maximum indices here is again 1. And indices at axis of array 2 is array of 1, 1, which is of type 32. So this is what you will get with the help of nan. So it will not check it will escape the values of nan. When it is not a number, then it will skip that value. So next thing is argmin. So it is the opposite of argmax. So in the argmax it will check the maximum value, whereas in the argmin it will check the minimum value. So here what is the minimum value we will check. So here I am using range of 8. So you will get from 0 to 7. I'm going to put array value. So then you get the value here from 0 to 7. And here I'm printing a minimum value of this among this. What is the minimum value? Minimum index value. What is the minimum index value or QAD? So you can have it in the output. So you are getting from 0 to 7 as I'm using a range of 8. The minimum index is 0 because 0 is a minimum number. And the index of this number is 0. So you read it like that. Coming to the next one, next functions like you can also use ndarray, where, non-zero, flat non-zero, where, search sorted, extract, all these things you can use. So this is all about searching. Whereas counting, as the name itself indicates that it will count. So what it will count? It will count the number of non-zero values. So it will count the number of non-zero values in the particular array which you are passing. So let me see here. So here I'm using the here a equal to input.count underscore non-zero reading. So non-zero values counting here. And so here I'm counting non-zero values as I have given here 3, 4, 5 non-zero values 1, 2, 3, 4, 5. And here also I'm counting 5 non-zero values. You can see here 1, 2, 3, 4, 5 like that. So how many non-zero values are there? It will count and it will give you here for A and here for B. So here I can observe that 1, 2, 3, 4, 5 non-zero values, and for the second value also here I can observe that 2, 3, 4, 5 non-zero values. So I will get number of non-zero values as 5 and 5 right here. This is all. Number of non-zero values is 5, number of non-zero values is 5. Like this you can work with counting, searching as well as sorting. That's all for this video. So in today's session we are going to see about random sampling in Numpy. So when you are hearing about random sampling, you will just hear about you just get into your mind about the probability, right? In probability we are going to use random sampling and all those concepts, right? So what do you mean by random sampling? So random sampling is nothing but giving from the total population, giving the equal probability to choose the sample is nothing but the random sampling. For example, if you are having a box, in that box if you are having 4 balls, choosing that each ball having the equal probability is random sample. That means choosing randomly, sampling is called as random sampling. So in this we are having a random function, random sample function, and random function, random integer function. All those things we are having. So let us see what it is. So first function is random. So what is this random is? It will give you the random integer values. It will give you the random integer values. See, for example, if you are trying to get a number randomly, the integer number, so you will use random function. If you want to get the random float value, so you will go for random function like that. So in random function, what you are going to give the parameters from? Here we give low value, high value. High value is optional and low value will be included and high value will be excluded. So you may think what is this low value and what is this high value and what is not all this. So if we are passing the values, like this is a syntax, numpy.random.value, low, high, size. So here I am passing the low value. That means from in the random function we will pass the low value. From which value? From the lowest value. What is the lowest value you want to give? So you will tell which value it is, the low value. And if you want to mention the high value, you will mention the high value as well. If not, high value is optional to you, and size. how much size you want, like how many random integer values you want. If you want 5 values, you will give us 5. And dtype is choosing the desired output data type. These are the parameters which we are going to give. So in the size, if you are passing the shape, if the given shape is like m and k value, m and k, and the sample which you are going to draw is m into n into k. That is what size meant. Size here you will. So let us see a simple example with one-dimensional array. So here is example. Here I am importing the numpy as coding with the alias name, and here I am writing the syntax as coding.random.randy as we have seen in the syntax. And low value I am mentioning 0 and high value is 3 and size is 5. We know that low value will be included and high value will be excluded, right? So this value, this thing is exclusive. That means it will take from 0 to 2, 0, 1 and 2. And the size you are going to give as 5. So see the output. And if I run the next time, the output will not be same. So check the output. It is not 21021, right? So if I run the output again, so you will get 1001. So that is what the value function. So once if you run, you will not again you will not get the same value. You will get the random values like that. So next example I am going to show you with two-dimensional arrays. So here you will see. So just now we have seen the single-dimensional array, right? Here you are going to change the size. This you will give 2, 3 like that. So here I have given the size of the array is 2, 3. I did not mention the height. So here I have given the low equal to 4. So it will take from 0 to 3. 0, 1, 2 and 3 it will take. And the size is 2 by 3 matrix. So output to the array is like 201 and 302. Again I am running here. So you will get the other output 310, 321. So this is how we will get with the random integers. So if you want the 3-dimensional array, you will give the 3-dimensional array size. Just you will change the size. Here I have changed the size as 2, 3, 4. So here then check the output, you will get the 3-dimensional array in this way. So if you run again, you will get the other 3-dimensional arrays. So the low value will be 2 and the high value will be 9. Then coming to the next one, random sample. So this random sample is will give you the float value in the half open intervals 0.0 and 1.0 like that. Half open intervals, and it will take the parameters as size and size. And the size is not mandatory, it is optional. So let us see the example. It will give you the float value. So see here, I did not mention the size. So you will see, you will get it with one value 0.2627. So again you will see 0.54 like this. So this is about float value with random sample. And with two-dimensional array, see, I have given the size as 1, 3. So you can check now. With 1, 3 what it is going to do. So see here the values with 1, 3 filled with random float values. So you can also give 3 by 3-dimensional array also. So like this 3, 2, 1. So you will get 3D array. This is how you are going to change the array size as well. According to the function you can change. Next is random function. So what is this random function is random float. You see here it will also take the random float value half open into 0.0 and 1.0. So you can have the parameters as size. So in the similar way, let's see with one example. So here I have used random. So you will get the random float values. So 0.059. You again check 0.7. Like this you will get. As example, if you want to with two-dimensional array, you will go with two-dimensional array. If you want with three-dimensional array, you will go with three-dimensional array. The next function is random integers. So this random integers, it is also seen like the random function, and it will also include your low value and high value will be exclusive in the intervals. So the parameters are like low, high, size, written, same parameters, and you can check the example, simple example. This is with the two-dimensional array. Let me take one example. So this is a two-dimensional array with the random integer values, and I have given low equal to size 3 and size equal to 3/3. So you will get like this. Like 3/3 matrix, you will get with this two-dimensional array. So this is how you can work out with this. And you can also see with the 3/3 matrix and this, you will have the low value, high value, and the matrix value, 3D size 2/2/3, m and k values like this. So this is how you will pass with that. And you will work with random integer values and random int and random sample. So apart from this, you are also having some more pseudo-random numbers. You can also work with this random.cdex, random.getState, all these you can have. So if you want, I will post this in the description box below, or you can see here. So python.org, then jobs, you will get all these random values. So like this. So this is how you can work with this. So I hope you enjoyed this video. So it is mainly important in probability, right? So this is how we will use. I hope you enjoyed. So in this session, we are going to see about universal functions. So what are universal functions? So in the universal functions, we are going to see about trigonometric functions, and then bitwise functions like bit-riddle, like that. And also we are going to see about arithmetic operations, all this we will see. So let us get into that. So in the universal functions, we are having some libraries also. From which library you are going to get all those things we will see. So mainly the universal functions in the NumPy are simple mathematical functions. So these functions, in these functions, it will include standard trigonometric functions, functions for arithmetic operations, handling complex numbers, statistical functions, all these things we are going to see. And we are having some characteristics of that function. These functions will operate, we know that it is in n-dimensional, NumPy is n-dimensional array, right? So in this, it will perform some various operations. So what are those characteristics is? First one is, as it is it performs fast element-wise array operations, and it will support broadcasting and typecasting. So what is broadcasting and what is typecasting we have already seen. I think you might know now. So, and also it will come from the numpy.ufunc class. So these universal functions, it belongs to numpy.ufunc class. So it belongs to the library. We will import from the library from pyfunc. This is the library functions. So these ufuncs are automatically called, like if you want to add two elements of the array, it is automatically called with np.add internally. If you want to subtract, it will go automatically called np.sum. So thus for the arithmetic operations, it will be automatically called with some functions. Coming to the next, trigonometric functions. We know that what are the trigonometric functions, right? Sine, cos, tan. These are it will compute sine values, cos values, and tan values. And whereas arc sine, this is the inverse of these values. Sine value inverse is arc sine, whereas cost value inverse is our cost of this. And hypot, what is this hypot is? If you calculate the hypotenuse, if you pass the value for base and height, if we calculate the hypotenuse, and it will give you the value. And here it is hyperbolic function sin h, cos h, and tan h. And these are the reverse of hyperbolic functions like arc sin, arc cos, and arc tan h. These are the reverse. And this is degree to radians. If you convert the degree value to radian values, then this will convert radian values to degree values. So let us see this with the help of a simple example. So in this example, we are going to see about sine values. How can you calculate these sine values, cos values, and all you are going to see now. So let me comment this. So here it is input numpy. I am calling numpy as NP and I am passing the array values like I am passing of 90 here 0, 30, 40, 60, 90, and 180. And here I am computing my degree to radians. I am converting degree to radians. And here I am calculating sine of angles. This angle will be calculated with sine. And here I am calculating inverse sine, and here I am calculating hyperbolic functions, and here I am calculating inverse hyperbolic. Here I am calculating hypotenuse values as I have given here base and height. So if you want to calculate this manually, it will take around 10 to 15 minutes to calculate all these functions, right? At least 5 to 10 minutes of doing, right? So if we are calculating here, we will get very fast, right? That is what programming is, right? So this is how you will get the value. See here, sine of the angles in the array. Sine 0 is 0. Sine 30 is 5. Sine 45, sine 60, sine 90, sine 180. These are the values. And inverse values is hyperbolic values. Inverse sine hyperbolic values. And whereas the hypotenuse values here base and height. Under root of 16 plus 9. We know that it is base square plus height square under root, right? So 16 plus 9 under root is 25 under root. So square root of 25 is 5. So we got it as hypotenuse as 5. So this is how we can calculate the values like this. So degree to radians and sine values, also calculate cos values and tan values here. In place of sine, we will place cos and tan here. So this is how you can calculate these things. Then next coming to the statistical functions. So what is the statistical function is? You can calculate median, variance, standard deviation, all this. So here we can also calculate minimum value, maximum value with A min, A max, and with PTP we can calculate the it will return the range of values like maximum to minimum range it will return, and it will calculate the percentile. It will also calculate the median, mean, standard deviation, variance, average, all this it will calculate. So let us see with the help of a simple program. So I have written a program. So let me see this. So here I have given weights as like this 50.7, 52.5. These are the different weights I have given. And minimum here I am calculating the minimum and maximum value. You can see here A min, NP dot T max, NP dot A min. And here I am calculating the range of the width to the this is PTP. With the help of PTP I am calculating range of weight max to minimum. And here I am calculating percentile, and here I am calculating mean, median, standard deviation, variance, and average. So let us see how it will give you the output. See here, minimum and maximum value. So what is the minimum value here? It is 45. And what is the maximum value? 33.25. So you got it as minimum and maximum. This is the range of the weight of the students. So what is the here I have given the range of the weight of the students. So maximum weight minus minimum weight you will get the range of the students. And weight here for the weight I have given weight, 70%. So you will secure the weight which is students is 70% below, so that they will fail. So what is the weight of that? So you will get from this. And next you are going to calculate the mean, median, standard deviation, variance and average. So mean is just you will calculate the values total plus number of values, then median, then standard deviation, variance and average. So this is how you can calculate here. See, if you want to calculate all this, it will take a lot of time for us, right? So if it is a simple function, if we are writing in a function, it will take less time, very less time, right? So that is, it is a beautiful thing here. So next we will see quick whittling function. So what is this whittling function? It will accept integer values as an input argument, and it will perform bitwise operations on binary representation. That means it will take the values, whatever the values you are giving, it will take as an input integers, and it will perform bitwise add or bitwise XOR or left shift, right shift, invert, all these things it will perform. So we have seen all these bitwise operations very clearly in one of our video, right? So I think you all know how to perform all these operations. Let us see here again how we are calculating here with the functions. So here I have given the even values and odd values, and I am trying to calculate bitwise and of those two values. So it will be bitwise and even odd. So for these two values I am calculating bitwise and bitwise odd and bitwise XOR, NOR, invert, left shift, right shift, all those things I am performing. So I will run this program. So see here, this is all the bitwise and of the two arrays. So 0, 1 we will get 0, 2, 3 we will get 2. So internally it will convert to binary values, and it will give you the it will take the and it will give you the output. So how to convert this and or all this we have seen in our video. So please, if you did not watch that video, go to that video and watch. So it will be helpful to you. I will recommend that. So this is how you will do with left shift, right shift, invert, all these things we have already seen in one of the video bitwise operations. So that's all for this video. So this will be mainly the main application where it is useful is it mainly in the researching things it will be used. So that's all for this video. I hope you enjoyed this video. Please like, share and subscribe. Thank you.